Last week you learned about monopoly and price discriminating monopolies, first degree, second degree, third degree. This time we're going to look at a different kind of monopoly, which is natural monopoly. So natural monopoly is the kind of monopoly that, as it sounds like, it occurs naturally, usually because there's major economies of scale. So for example, having a utility company like Excel is considered a natural monopoly, even if they weren't chartered by the government, because it costs so much to start up a utility company, costs so much to build the generators, nuclear power plants, whatever other kind of coal burning power plants, and it's extremely expensive to build for just one customer, right? But the marginal cost of serving additional customers is extremely, extremely low, and it stays low for a very long time. So if you look at this graph, what you see is very similar to another monopolist in terms of demand and marginal revenue, but you can see that both ATC and MC fall over a very long period of time. And it doesn't necessarily look like they're extremely high, right? But they're high and falling, and marginal cost continues to fall. So rather than dropping very briefly and then heading back up and dragging ATC up, MC continues to fall because it's relatively cheap to keep adding more and more and more and more customers. So ATC continues to fall, and often when you draw a natural monopoly, you draw it so that ATC and MC have not crossed within the main space of the graph. So you know they're going to cross at some point, but they haven't crossed yet. So we can see from this graph that we still have the same scenario, right? That left alone, the natural monopolist would produce where MR equals MC and would charge this P1, right? And that is really not the ideal situation because they're charging a whole lot more than their marginal cost of production, and they're not serving very many customers. So the question is what to do. Unlike other monopolies, we don't necessarily want to break them up, because if you made a bunch of small firms instead, you would end up with much higher average total costs. You can see how average total costs rise. Well, that's not efficient, right? What we want is more production, not less, from a natural monopolist. So there are two ways that have been used, primary methods for regulating natural monopoly. The first one is what we call socially optimal pricing. Okay, and the idea is to achieve allocative efficiency. So we're going to require the monopolist to charge what we call a socially optimal price. And we determine that by looking for where demand and the MC curve intersect. So if you look at that right here, that means that the price that the last customer is willing to pay is equal to the marginal cost of serving that last customer. Okay, that is theoretically, remember, the monopolist, if the monopolist were to be in perfect competition, the marginal, where marginal cost crosses demand, would be the perfectly competitive outcome. So same thing going on here. We decide we want this level of output, right? And so what we do is we put in place a price ceiling at this price, and we tell the monopolist, you have to charge everybody no more than this. Okay, you can't charge them any more than that. And that will force the monopolist to then produce to this level. But there's a problem you can see, right? And that is that this price at this level of output, and actually at any level of output, but certainly at this one, is actually below ATC. So if we did this, we would actually be forcing this monopolist to take a loss. And monopolists who've been regulated this way have actually sued the U.S. government and said, you can't force us to take a loss. You're denying us, due process. You're denying us private property rights. And the Supreme Court agreed with them. So the regulatory commissions came up with a new way to ensure that monopoly owners actually get a fair return. So fair return pricing is when you actually set the price at the point where the ATC curve crosses the demand curve. So that point was on this graph, right, but we didn't look at it. What's significant about this? At this price, at this level of output, the monopolist is covering all of their costs, right? They are actually able to pay all of their bills. They just don't have any economic profit. So this is considered a fair return price when you have a price ceiling right here. So the price is higher than the socially optimal price would be over here, and the output level is lower, right? But it's a much better outcome than if we just let the monopolist do whatever he or she wanted, right? That monopolist would charge P1, right? And they'd only produce Q1 level of output, and fair return pricing would produce a much lower price and almost twice as much output. So that's better than breaking up a natural monopoly and forcing lots of small producers to produce a very high ATC. Okay, so here's a question you can look at, and these are some of the questions about it. So I want you to look at it for just a minute. You should pause this video, and then I'll come back, and when you hit play again, I'm going to tell you the answers. Okay, so here are the answers for this graph. What price would the monopolist set? For a monopolist, you want to look for where MR crosses MC, right? And go up to the demand curve, and it tells you the monopolist would charge P2, and they would produce Q2 level of output. What would be the output level if the monopolist could price discriminate? We want to look for where marginal cost crosses the demand curve, because they produce the allocatively efficient level. So we don't ask in this question, that's Q5 by the way, we don't ask in this question what would they charge, because they would charge every customer a different price. What price would be socially optimal? Socially optimal price would be P5, right? That would, of course, be below ATC. Output level of socially optimal is Q5. What price would ensure a fair return? That would be P4, and output level Q4. All right, here's another one. All right, and again, it would be a good idea to look, if you've printed out the notes, look at these questions and pause, and then I'll come back and answer them. Okay, profit maximizing for the monopolist, if the museum is a monopolist, would be, of course, where MR equals MC. So they would produce Q2. They would have Q2 levels of tickets sold, and they would charge P5. They would maximize total revenue at the point of unit elasticity, or the point where marginal revenue is 0. So that would be at a price of P3, output Q4. Maximizing consumer and producer surplus, that would be socially optimal output. So that would be P4 and Q3 right here. Maximizing attendance as long as they break even, that would be right here, right? Break even point of ATC equals the demand curve. And let's see, when attendance is Q1, is demand price elastic, inelastic, or unit elastic? It would be elastic, because anything to the left of where MR equals 0 is going to be the elastic range of this demand curve. That is maximum total revenue, sorry, right here. Where MR equals 0 is maximum total revenue, and below that you're in the inelastic range. Assume the price is set at P2. Assuming the existence of an opportunity cost, indicate whether the museum's accounting profits would be positive, negative, or 0. At P2, they break even, so the accounting profits would be positive. Assume the government decides the museum should charge no admission and agrees to subsidize. Okay, well, if they charge no admission, the price is free, right? And they would be way over here. I didn't even label that. Would that be allocatively efficient? No. In fact, that would be a huge amount of waste. Right, the museum would take a huge loss. You can't even see ATC on here, and we can't even imagine what the marginal cost of production would be. So no, it would not be allocatively efficient to have free admission. Okay, now we're going to move on and spend a little bit of time on monopolistic competition. So monopolistic competition, the graph looks very much like the monopolist graph, the biggest difference being that the demand and MR curves are much flatter, right? They're much more elastic. So as it says here, the monopolist competitor can see the demand curve, and he produces where MR equals MC, same thing, and charges what buyers will be willing and able to pay. So you can see here, this little aqua kind of box is actually this monopolistic competitor's profit. The primary difference in this graph is the elasticity of the demand curve. It's much more elastic. Why? Because there are substitutes, right? Unlike the monopolist competitor faces substitutes. So the demand curve can actually shift when new competitors open the market or when they leave. What will happen if this firm is making a profit? Well, it'll be an incentive for other firms to join this market. So here's what happens. Other firms enter the market. Barriers to entry are low, right? Everybody's just a little bit differentiated. Demand and marginal revenue both shift to the right. So we go from D1 MR1 to D2 MR2, right? We've lost quite a bit of our market share. And now the profit maximizing output level, where MR crosses MC, the price on the demand curve is below the ATC. So this scenario wouldn't really happen with monopolists, right? They just go out of business. But for monopolistic competition, they might stay in business in the short run if they're covering their average variable costs. But eventually some will leave the market. And once some firms in this market, some of the jeans manufacturers leave the market, demand for the others will shift back to the right. So, doesn't show you on here the equilibrium. The equilibrium position for a monopolistic competitor is actually going to be where you have a break even and no profit, and that will happen when the demand curve is tangent to the ATC line. So the demand curve would shift back to be tangent to the ATC line, And if you're going to draw that, you have to draw it in such a way that that at that point of tangency, the margin, that's where I mark crosses MC. So I have a little bit of a hard time drawing it, but that's what would be happening there. All right, last part for today is talking about oligopoly. And oligopolists are best explained and analyzed and studied through what we call game theory. So I'm going to run you through game theory quickly, and then we might spend a little bit of time on it actually in the session. So in game theory, you have three basic elements. The players. This game has two players, Pepsi and Coke. The strategies available to each player. Their two strategies are advertise or don't advertise. Okay, both players face the same two choices. And the payoffs each player receives. And the payoffs are what's represented in this payoff matrix. Okay, how to read this matrix? First of all, I color-coded it, but normally they're not going to be color-coded. So always the firm that is on the left is going to be represented by the numbers in the matrix that are on the left. And the firm that is up top is going to be represented by the numbers on the right. So I color-coded it to help, but you need to be able to practice with just black type. You need to look at the strategies and the payoffs for each player. So what happens if they both advertise? The numbers on this matrix represent maybe increased profits or increased revenues. So if they both advertise, Pepsi gets 80, Coke gets 80. If they both don't advertise, they both get 100. Why? Because they're not having to pay for the advertising. But if Pepsi doesn't advertise and Coke does, you can see that Coke will get 120 while Pepsi will only get 45. So they'll be at a disadvantage if Coke advertises and they don't. And this is really the premise of game theory, is that in oligopoly, firms make decisions based on what they expect their top competitors to do. This doesn't happen in monopoly because there aren't competitors. And in both perfect competition and monopolistic competition, there are so many competitors that it's impossible to base your strategy on just one of them. Okay, so, I was thinking I had something else on here. So I'm going to come back to this for just a second. The way that we read this to figure out what they're going to do, what we're doing is we're looking for what we call a dominant strategy. So we look first from Pepsi's perspective, and we look at the first column, and we say if Coke advertises, what should Pepsi do? Should they also advertise and get 80 or not advertise and get 45? Well, clearly they should advertise and get 80. Then we move over to the right-hand column. What if Coke doesn't advertise? Should Pepsi advertise and get 120 or not advertise and get 100? Well, again, advertising looks like the better outcome. So if Coke advertises, Pepsi should advertise. Coke doesn't advertise, Pepsi should advertise. Both indicators tell us they should advertise, so that is what we call a dominant strategy. And we can predict that that Pepsi will advertise. Do the same analysis with Coke. What if Pepsi advertises? Now we're going to read horizontally. If Pepsi advertises, should Coke advertise and get 80 or not advertise and get 45? Well, clearly they should advertise. What if Pepsi doesn't? Again, 120, 100. So we can predict that Pepsi will advertise, Coke will advertise. They have a dominant strategy. Each of them does. And that is a Nash equilibrium because neither firm has any incentive to change. When you see some payoff matrices, like the prisoner's dilemma, the numbers actually represent here years in prison. So the numbers are bad, so you want to look for low numbers. So pause for a second and solve this and tell me what the dominant strategy is. Well, I'll tell you. Okay. If you said that the dominant strategy is that both will confess, you are correct. They will both confess. Why will they both confess? Chris will confess because when Pat confesses, 5 is better than 10, right? 5 years in prison is better than 10. And if Pat denies, 1 is better than 2. Okay, you'll notice that the same choices apply to Pat. All right, so this is just a summary, okay? And this also explains because they often end up, you can see, advertise is actually a worse position for both of them than don't advertise. And this is why oligopolists have a strong incentive to collude or work together to overcome those forces.